Alright, let's look at the last few examples here. On this one, it looks like it's a trinomial, and it looks like there is a common factor of 3z. When I factor out the 3z, I'm left with z squared. That's from this term. From this term, I have a 4z, and from this term, I have a negative 5. So now this trinomial matches the correct form. It didn't match the correct form before, so I couldn't find the two numbers whose product is one thing and its sum is another. But now that it does, I can do m times n equals negative 5 and m plus n equals 4. So the only way to get a 5 is 1 and 5. And if I'm looking for a sum of 4, also product of negative 5, not positive 5, it looks like I'm looking for a negative 1 and a positive 5. So this factors as 3z times z minus 1 times z plus 5. On this one, let's see, looks like 3 is a common factor. A is not present in all of those, so it's not a common factor, but there is a b squared in each of them. So my greatest common factor is 3b squared. Let's figure out what's left over when I factor out 3b squared. I have an a squared minus 8a plus 12. This one, 24 divided by 3 is 8, 36 divided by 3 is 12. And the b squareds kind of, they get factored out as well. So I'm looking for two numbers whose product is 12 and whose sum is negative 8. So 1 and 12, 2 and 6, 3 and 4. Those are the different ways I can multiply numbers to get together to get 12. Here I'm seeing this is the sum right here is positive 8. I'm actually looking for a sum of negative 8, and that's an easy enough thing to correct for. If they're both negative, the product is still going to be positive, but the sum turns out correctly here. So we end up with 3b squared times, let's see, a minus 2 times a minus 6. On this one, when we're factoring out our greatest common factor, it may not look at first like there is a greatest common factor, but that the leading coefficient is still negative, and we still have that restriction when we're factoring things. If the leading coefficient is negative, we have to factor it out. So we end up with w squared plus 5w minus 24. You'll notice it changed the sign of both of those because I factored a negative out. Actually changed the sign of all three terms. This negative is not on just that term. It's, you'd have to distribute it to all three. Alright, so now we're looking for m times n, two numbers whose product is negative 24 and whose sum is 5. 4 and 6. 5 doesn't go into it. 6 is already covered, so there's our list. We want the product, or we want the sum to be 5. Oh, we also want the we want this to be negative, so I'm just going to throw it on one of these. We want the sum to be 5. It looks like this one right here is the one we're looking for. So the opposite of w minus 3 times w plus 8. So you'll notice when I'm doing this, I'm breaking up the trinomial into smaller bits. Whatever was multiplied out in front still stays there. It's going to remain when we're factoring. Alright, looking at this one, we have a negative, so I'm going to factor a negative out. And there's also a 2 that's in common between each of the things. There's also an a. So negative 2a is my greatest common factor. So when I factor a negative 2a out of that part, or divide it out, we're left with an a squared. A negative 2a factored out of this is plus 4a. And a negative 2a factored out of that is negative 12. So we want our two numbers whose product is negative 12 and whose sum is positive 4. We'll throw the negative on one of these. That looks like that's the pair I'm looking for. So that's how it factors.